Welcome back. Back to Let's Get Rusty. My name is Bogdan, and this channel is all about the Rust programming language. If that sounds interesting to you, make sure to tap that subscribe button so you can get Rust videos every single week. Last time we went over chapter 7, in which we talked about managing large projects using Rust's module system. In this video, we'll go over chapter 8, which talks about common collections. Collections allow you to store multiple values, but unlike arrays or tuples, collections are allocated on the heap, meaning the size of the collection could grow or shrink as needed. Specifically, we'll talk about vectors, strings, and hash maps. So with that, let's get started. The first collection type we'll talk about are vectors. Here I created a new package called collections. In the main, I've defined an array called A, and it contains signed 32-bit integers. So now let's create a vector of signed 32-bit integers. We'll call our vector v, and we'll specify the type as a vector of signed 32-bit integers. And then we'll set that equal to vec : new. Here we're calling the new function on the vector type, which will create an empty vector. Now vectors can hold any type of values, and because we're not initializing the vector with any values, Rust can't infer what type we want. So here we have to specify the type using generic syntax, and in our case it's signed 32-bit integers. Now a vector can grow in size, so even though this vector is empty right now, we can add elements to it. To do that, let's make the vector mutable, and then we can call a method called push to push elements onto the vector like so. So here we're pushing 1, 2, and 3 onto our vector. Now, if we wanted to create a vector and initialize it with values at the same time, Rust has a convenient macro for that. So let's create another variable called v2. And we'll set that equal to vec, exclamation point, and then specify the values we want to initialize the vector with. This looks very similar to our array initialization, except that we have the vec macro specified in the beginning here. And notice that we didn't have to specify the type explicitly, and that's because Rust couldn't infer the type from the values we passed into the macro. Note that vectors, just like any other type stored on the heap, will be dropped when they go out of scope. So to illustrate this, let's put our v2 variable in its own scope. When this scope ends, which is right here, v2 will be dropped. Also, all the elements inside of our vector will be dropped as well. Now let's talk about accessing elements inside of a vector. Except that we have the vec macro specified in the beginning here. And notice that we didn't have to specify the type explicitly, and that's because Rust couldn't infer the type from the values we passed into the macro. Note that vectors, just like any other type stored on the heap, will be dropped when they go out of scope. So to illustrate this, let's put our v2 variable in its own scope. When this scope ends, which is right here, outside of a vector, there are two ways to access elements, and the first way is to directly reference an index in the vector. As an example, here I have a vector called v with 5 elements, and what we'll do is access the third index. Here we create a variable named third, which is equal to ampersand v, and that specifies a reference to our vector. And then we use brackets to specify the index we want, and it's 0 based. So if we want the third index, we specify the number 2, and then we just print our variable. Let's go ahead and run this program. We'll type in cargo run, and we see that the third element is 3, which is correct. Now the problem with this approach is that we can specify an invalid index. For example, instead of 2, let's put 20 here. Now we don't have an element at the 21st index, so when we try to do cargo run, we'll get an error. Here we get an index out of bounds error, which says that the length of our vector is 5, but the index we specified is 20. Now notice that this is a runtime error. If we used an array and tried to access an index that was out of bounds, we would get a compile time error. So the program wouldn't even run until we fix the error. And that's because with arrays, we know the size of the array at compile time. But with a vector, we don't know the size at compile time. Vectors are stored on the heap, so they could be of variable size. All that to say, if you directly reference an element in a vector, then you're saying, I expect my program to crash at runtime if an invalid index is used. But let's say you don't want your program to crash if an invalid index is used. Instead, you want to handle that case gracefully. In that situation, Rust provides a safer way to access elements in a vector using the get method. Let's change this 20 back to 2. And at the bottom here, we'll use the get method to access the third index. Now here, instead of getting a reference to the third element directly, we're calling the get method and passing it our index. And the get method, as you can see here, returns an option. You might recall from my video on enums that the option enum represents some value or no value. Here we use a match expression to handle both the sum case and the none case. In the sum case, we get our integer and store that in a variable called third, and then we print the variable out. In the none case, we print out that there is no third element. Let's comment out the print line statement up here. And run our program again. And we get the expected output, the third. Third element is 3. Now let's change this to 20. And we'll run our program again. This time, instead of throwing a runtime error, our get method returns none because there is no element at the index we specified. So we execute the code in our none branch. So again, if you want to handle index out of bounds errors gracefully without crashing your program, you would access elements on your vector using the get method. Now, when we access elements in a vector, we are getting a reference to that element. And if you recall in the video I did about ownership in Rust, there are some rules around references, namely that you cannot have a immutable reference and a mutable reference to the same thing at the same time. For example, let's say after we create this third variable up here, and before we print it out, we want to add an element to our vector, like so. And we'll need to make our vector mutable. Now if I uncomment this print line, you see that we get an error. And the error states we can't borrow v as mutable because it is already borrowed as immutable. On line 4, we take an immutable reference to a value in the vector. On line 5, we take a mutable reference to push a new element onto the vector. And then on line 6, we use our immutable reference that we created on line 4. This is a problem because when we have an immutable reference to something, we expect the underlying value to not change. But if we have a mutable reference to the same thing, then the underlying value could change. And the way that happens with vectors is that when we push a new element onto a vector, we might need to allocate more memory to make room for that new value. And when we do that, we need to move all the elements in our vector to new memory locations. And if that were to happen, then our variable we declared here on line 4 would be pointing to something else. Now let's talk about iterating over elements in our vector. For example, let's say we were pointing to something else. And if that were to happen, then our variable we declared here on line 4 would be pointing to something else. Now let's talk about iterating over elements in our vector. For example, let's say we want to iterate over all the elements in our vector v and print them out. To do that, we can use the for in loop. So we'll type out for I in, and then we'll take a reference to our vector and print out each element. Let's run our program, and we get our list of elements printed out. What's happening here is we're looping through all the elements in our v vector, and we're taking an immutable reference to each element and then printing it out. But we could also take a mutable reference and then modify the value. Here we're using the dereference operator to get the underlying value and add 50 to it. We'll learn more about the dereference operator in chapter 15. Underneath this for and loop, let's print out all our values again, and then we'll run our program. And you can see that all the values in the vector have 50 added to them. The last thing I want to talk about with regard to vectors is storing enum variants inside of 50 added to them. Pointing to something okay, we print it out, we want to add an element to our vector, like so. We're adding a reference to that element. Errors gracefully without crashing your program, you would access elements on your vector using the get method. Now, when we access elements in a vector, we are getting a reference to that element. And if you recall in the video I did about ownership in Rust, there are some rules around references, namely that you cannot have a immutable reference and a mutable reference to the same thing at the same time. For example, let's say after we create this third variable up here, and before we print it out, we want to add an element to our vector, like so. Type out an vector, and we're taking an immutable is storing enum variants inside of a vector. As I've mentioned before, vectors can only store one type of data. But let's say we want to store different types of data. In this example, we want our vector to represent a row of cells in a spreadsheet. Each cell could store either an integer, a floating point number, or a string. In order to represent this in a vector, we can create an enum that represents the cell. We'll call it spreadsheet cell, and then create variants for each type of data. In this case, we have an int variant, a float variant, and a text variant. Now remember that all of these variants are under the same type, which in this case is spreadsheet cell. So we could create a vector of spreadsheet cells, and then inside the vector we could have different variants. Now the only catch is when you reference a specific element inside of the vector, you have to use a match expression to figure out which variant of the enum it is. And that's because our vector is of type spreadsheet cell. So here we're referencing the second element in our vector, and we're saying if it's an integer, then print out the integer. And if it's anything else, print out not an integer. All right, now let's talk about strings. And before we start, enum to represent a row of cells in a spreadsheet. Each and you can see that all the values in the vector have 50 added to them. The last thing I want to talk about with regard to vectors is storing enum variants inside of a vector. As I've mentioned before, vector
just fine before I met you. I drink too much and that's an issue, but I'm okay. Hey, you tell your friends it was nice to meet them, but I hope I never see them again. I know it breaks your heart. Moved to the city and I broke down crying. 4 years, no calls. Now you're looking pretty in a hotel bar, and I can't stop. No, I can't stop. So baby, pull me closer in the backseat of your Rover that I know you can't afford. Bite that tattoo on your shoulder. Pull the sheets right off the corner of the mattress that you stole from your roommate back in Boulder. We ain't ever getting older. We ain't ever getting older. We ain't ever getting older.
You look as good as the day I met you. I forget just why I left you. I was insane. Stay and play that Blink-182 song that we beat to death in Tucson. Okay. I know it breaks your heart. Moved to the city and I broke down crying. 4 years, no call. Now I'm looking pretty in a hotel bar, and I can't stop. No, I can't stop.
So baby, pull me closer in the backseat of your Rover that I know you can't afford. Bite that tattoo on your shoulder. Pull the sheets right off the corner of the mattress that you stole from your roommate back in Boulder. We ain't never getting older. We ain't never getting older. We ain't never getting older. So baby, pull me closer in the backseat of your Rover that I know you can't afford. Bite that tattoo on your shoulder. Pull the sheets right off the corner of that mattress that you stole from your roommate back in Boulder. We ain't ever getting older. We ain't ever getting older.
We ain't never getting older.
We ain't ever getting older.
We ain't never getting older. We ain't never getting older. No, we ain't never getting older. We ain't never getting older. No, we ain't never getting older.
Alright, now let's spin out the integer.
Come on, turn the radio on. It's Friday night and I won't be long. Gotta do my hair, put my makeup on. It's Friday night and I won't be long till I hit the dance floor, hit the dance floor. I got all I need. No, I ain't got cash, but I got you, baby. Baby, I don't need dollar bills to have fun tonight. Baby, I don't need dollar bills to have fun tonight. But
the CIA triad is an easy way to remember the fundamentals of IT security. Sometimes you'll see this referred to as the AIC triad to differentiate it from the federal organization in the U.S. called the Central Intelligence Agency. But since it's so easy to remember CIA, we often refer to the CIA triad instead of the AIC triad.